right, welcome back to another coding session. This is part 2 of our refactor. In the last session we got it so that our compiler is compiling with the refactored code, but we had a runtime error. Here it is, and I imagine there's going to be a lot of them. So we're going to work through all those, hopefully get to a point where we have our code running successfully, and then depending on how much time we have, we might come back to doing our type aliasing, because I think that's, with this refactor, I think that's not going to be actually too hard to do. Okay, so I think we just get stuck into it. This here is we're checking whether we're doing type checking and we want to do procedures first. Well, we want to add procedures to the identifiers first. We're checking whether the type information on the left-hand side of an assignment is a procedure, but not all assignments have that type information at this stage. Actually, most probably don't. So I think we just need to check that that exists, because we've got a null. You know, it's null, and that's the problem we have here. So let's try that. Okay, I think this is probably something very similar. Yeah, we're looking at the left-hand side type information, which if it was annotated, you know, if we had something like this where the left-hand side was annotated, then that's fine. But if it was not, there might not be type information on the left-hand side yet. So let's just do another check. Easy peasy so far. Okay, so the left-hand side node, well, our node, no, the parent node is an identifier. So why are we coming in here? Ah, that's right, I saw this before. I don't know how we managed to finish, like a couple of sessions ago, we changed this, and I put this condition wrong. Should be not binary operator to go in here. And somehow I missed it. So I think there's the same thing here, yeah. So let's correct those and see what happens. All right, another error, great. I guess this thing here is failing. So maybe let's just grab this and have a look at it. Blah is an identifier with message, and we wanted to get the type of it. So it has a child string, which is also an identifier. So really that needs to be a type, needs to be upgraded to a type. So I had thought about this, but we didn't get around to it. But I was thinking up here in our initial pass, what we could also do is resolve types. I think we have to pass the context in as well. We'll do a step here so that basically it will recursively look through all of the code, and wherever it finds an identifier that has a matching entry in the identifiers list, which is a type, then it will replace it. So that all of our identifiers which refer to types become types, because we need that for later on. So let's create that procedure. So we need a node and a context, and so what do we need to check? So if we're looking at an identifier, I guess there's a few places where we need to check whether we're looking at an identifier, but the trick is that sometimes that could be referring to the member of a struct, although at this point I think we have to ignore that. I think we'll just do like node.value in context.identifiers. So if it's in the identifiers, then let's grab the identifier node. And if the identifier node type, type is type, then let's replace that node like so. Why is that a problem? Oh, because we actually need to grab the element out of it. I think that should be okay. So that should replace any nodes, any identifier nodes that are referring to that. Yeah, I think that should be enough conditions. And then we recurse. So because we want to go through all the code and do this. So resolve types, child node context. So that's our resolve types, which we call right up here. So then whenever we go into type check statement, we should find that all of the types have been substituted correctly first. Oops, I accidentally closed generation. Keep that open. Okay, so now we've found ourselves somewhere else. So we are type checking an assignment, and the left-hand side type node procedure does not have any children. Well, that's a bit strange. So where could this be happening? Well, let's go. Well, there's this here that could be doing it. So let's just check before we get to there. Left-hand side node has a child, which is procedure, which has no children. Okay, so it's not this, because before we go into this, it's that. It's like that. Then if we go to parsing, it would be parsing the left-hand side. Actually, which procedure are we talking about here? Let's take that away for now. So the left-hand side node is right. Okay, so it's right at the start of our standard lib. It's the very first line that we try to parse. So that's good. So we can just put a breakpoint here. Step over, and we should see that we have right here. The type node is a procedure with parameters. So it's fine at this point. Yeah, it's fine at this point. So if we step out, and we step over, I don't see how any of this would change it. The type is, yeah, procedure parameters. So everything looks good. And then we do use the assignment node. And the left-hand side is this, which is a type of procedure, which has parameters. Yeah, so everything's fine. A parsing seems to leave it intact. And this seems to, so I feel like this is kind of what's in between. Would it be this? Let's have a look here. So the left-hand side node is right. Children is procedure, and it has no children under it. So maybe it's this resolve types. Let's go here. The node value is, okay. We're looking at a type, so we should only do this for identifiers. Okay, that solved that. All right, we're getting somewhere. So this here looks suspiciously like, if we go to line 3, yeah, it's because we have untyped here. So this is a string, this is an I64 too, and this untyped should mean just use this type, but that's not being handled here. And I think I have an idea about that. So in our identifier, is it an identifier? No, in our index code, we have this thing which is supposed to propagate. No, that's boundless. Untyped. Untyped, I think, because untyped is on the node. Untyped is on the node. If we go to parse primary, and here, see, we put the directive just directly on the node now. So I think during type checking, we have this thing here where we're checking the directive that was on the type node, but not on the node. So I think if there's one on the node, I think that should take precedence, because that's kind of like been more directly associated with this identifier. So if it does not equal empty string, we use that. Otherwise, we do what we did before. I'm not sure if it's necessary, but I'm going to put it in brackets just so it's a bit clearer for me. Oops, I should have done debug. Okay, now we have a different error. Type node is null. Expected type node is null. Because it should be null in this. We're not expecting anything. So that makes total sense. So I think what we're going to do is just say, we're just going to allow that it can be null and just return no. I think that should solve that one. Okay. We haven't added the type information to node yet. We do that here. But I'm wondering if this is the right place to put it. I think it should actually go there, and we should actually be checking the child, because the type of this is the individual element of whatever we're indexing, but it should go on the array. I think that's right. I don't. Let's see. Okay, So now the code is executing, but we have an error. So if we go to the tests, it's this declaration of array, no declaration of pointer. That's failing. So what I'm going to do is I'm just going to isolate this code as much as possible. It refers to I0, so we'll keep that in. I think that's all we need. So it fails, and now we can look at the assembly, and immediately we see it's not allocating. It's putting something on the top of the stack, but it's never allocated some space on the stack. So that's in generation, generating an assignment. This is where we allocate. So this is a problem because we're always going to have at least one child. I think what we're trying to say is if this is a member, a struct member, this thing here, then we don't want to allocate. I think I might make a utility for that and just say is struct member. We'll put it in type checking because I think we need it here as well. We need to change some things to use this here. So we're taking a node and return a ball. And I think we want to return like the node type is identifier and the length of its children is greater than 0. And the first child was also an identifier. I think that makes it a struct member. Let's see, we'll go with that for now. So we want it to not be a struct member to allocate. Okay, we're getting a different error here. So I guess if we look at the tests, we see now it's allocating. So that's nice. Let's uncomment all those and see, just make sure the tests run. Okay, great. It's our example still that's throwing errors, so the tests are all good. That's very nice. And this is the boundless stuff, which we chose not to take care of before. Here it is. So let's have a look at this now. Yeah, that's right. I wanted to have this print out because I think that makes it a bit more obvious what we need to do. So here we have if A is boundless and B is not, if A is not boundless and B is. And that's the case we have here, right? A is not boundless, B is. So what we're going to actually do is recurse. Because in this case, what we're actually interested in is this versus this. Are they the same? Because a boundless reference is kind of like a reference to an array, but it doesn't have a length. That's kind of the difference. So once we dereference these two, this is really what we're looking at. Are these the same? So in this case, where A is not boundless, the child of A is this array, and then the child of that is this. So that's what we want. So we're going to say, whoops, we're going to say the child of the child so that we get to this. And on this side, we just have a reference to an I8, so we just need to get the direct child. And we want to compare those. That's basically it. And then the other way around is just that we do child of the child over there. I think that's it. Let's try it. Hey, we've got our triangles and our FPS counter. So that didn't take too long, 20 minutes, and we fixed all the errors, well, all the errors that prevent that particular program from running. Just as an extra check, let's try this other. I really should put this stuff in the test code. This really tests, I feel like. Let's see if that works. That also works. Great. Okay, so since that only took us 20 minutes, let's see if we can get this working. We want our struct to be called foo, so then we should be able to put foo here, and foo there. Yeah, let's just try that for now. That's going to be a bit of a grammar change. So now we're saying the right-hand side primary can also take the struct type and procedure type. You know, it can appear on the right-hand side of an assignment. So if we go back to our grammar, where is it? Here we go. Struct type, procedure type. Let's put that there. And while we're looking at that, let's modify our parsing so that it actually is working properly, because at the moment we're not restricting things correctly. So I'm going to create a primary type. I'm just going to put it in this file for now. I honestly don't know where the best place for it is. Oh, come on. I want it to say enum. Say none, LHS, RHS type. Those were the primary types. Okay, so we have a few places where we recurse. Let's fill those in. Like so. And now instead of doing this, I'm going to let all of them go through all the cases, and then I'm going to put some errors in here to handle what they should and shouldn't be able to do. So if we look at the grammar, and what is the first thing we're dealing with here? It's a directive. What can have a directive? Right-hand side and type can both have directives, but left-hand side it looks like cannot have a directive. So let's say if type equals left-hand side, we want to throw an error. How do we throw an error? Where's an example of an error? Here we go. So we throw an error and we say left-hand side primary cannot contain a directive, like so. Okay, now the hat. So these two again can have the hat, but the left-hand side, it does have a hat, but it's after the primary. These ones are before the primary. So the one before the primary, again, it's cannot be referenced. That's what it's saying, eh? On the left, that's a reference. Yeah. Sorry, what's the next one? Minus, I think that's only right-hand side. Yeah, only a right-hand side can have a minus. So let's say if it's not right-hand side, let's say only the right-hand side primary can be negated. Only a right-hand side primary. I feel like these are maybe not the best error messages. Like, it makes sense to me because I know the internals of things, but yeah, maybe it doesn't really make sense. Anyway, we can improve them later. The important thing is that there is an error. So opening bracket, so that's a sub-expression, which is only, that's this one here. No, it's not. This here, expression in brackets. So it's only for right-hand side nodes. Only a reft. Only a right-hand side primary can contain a sub-expression. Okay. Now we go to identifier. Everything can contain an identifier, right? If identifier, identifier, and identifier. So that's all good. But the call only appears on the right-hand side. So we'll put this here, say on the right-hand side primary can contain a call. Go down to keyword, struct and proc. So left-hand side cannot contain these. So we'll say a left-hand side primary cannot contain a type literal. I'll just say that for now. These literals can only appear on the right-hand side. So only a right-hand side primary can contain a string literal, C string literal, number literal, Boolean literal, nil. Is that really the right-hand side is the only place that we can have a nil? Yeah, I guess so. Yeah, so that makes sure all of those, and then this switch here is things that come after the primary. So on the left-hand side, it could be a hat or an index or a dot. Right-hand side could be also hat or index or dot. And the type can only be index. So for hat, we say we can't do it for that. So a type primary cannot dereferenced. Everything can have the index, but the period type primary cannot access a member, something like that. Okay, so I think that properly restricts things. Right, now we need to say the proper things. So this is a left-hand side expression, so it's obviously left-hand side, but this here is for the type, so that's the type. This is the right-hand side. Right-hand side. Some more down here, it looks like. So this is for a type. I think there's going to be a few for type down here. This is also for a type. Or did I skip past one? That's also for a type. Okay. Runtime assertion, question, question, question. Yeah, so I wasn't sure if types should come in here. And should they? Should we be type checking a primary for a type? I feel like we shouldn't really, like there's nothing to do, I think. If it's been resolved to a type, the work has been done. So I feel like we should be able to prevent that. So right-hand side expression. So the right-hand side node, we know it's a type. I feel like we can say if not is type, the right-hand side node. If the right-hand side node is a type, then there's no type checking to do, you know? Okay, and this again is where the right-hand side is a type. So this is where we were appending the type information, but since this is a type itself, getType is going to not return anything. We need to handle this specially. So we do something something else. Yeah, not this. We want to set the left-hand side node to be the right-hand side node. Like that. And this here, I guess, if it's not a type, let me throw that. Oh, this is, what about struct member access? So not a struct member. That's what I was talking about before. What's wrong with that? Why don't we have right-hand side node? Oh, because we don't know if the, actually it's the left-hand side node we're talking about anyway. So now if we are talking about a type, we don't, no, we do want to put it in. Okay, let's see what happens. Let's see what happens. Okay. So the identifier is my struct with foo. And foo is just an identifier, so it hasn't been resolved correctly. So if we look back here, where we added in, we do add it in, right? I'm a little bit suspicious. It should be, well, yeah, I think that should. So the right-hand side node is a struct. So this name, where is this name? This is just going to become a struct type node, and it's not going to have the correct name. So when we come down here, that's not going to be the name. Okay. So we kind of need to save the name first. I think what we might do is put all this stuff in an if statement. So this is just for when it's not a type. We do this. We do this like here. But first, we save the name. And then we use that name like that. Because when we do this, we're killing the name. Yeah, I think that's good. Okay, let's try that. We're back here. We should remove this line. So it's a struct type. So this is the assignment, my struct. Okay. And we type check the left-hand side, which includes a primary. Yes. And the child of that is an identifier, which is foo. So foo is still an identifier at this point. At this point, foo is an identifier. We need to make sure we evaluate this before we get here. It should be evaluated though, right? I mean, why wouldn't it have been? That should be evaluated, then this should be evaluated. So that should put the type in. Let's just double check here that it is. Where is it? Here. So the name is foo, and the left-hand side node is a struct with 2 children, and they seem to have all the right type of information. So that's getting put in. Blah is a type. What is the node? It's the identifier foo. Why is foo an identifier? Oh, wait a minute. Because we replace the types. We're replacing the types up here, but we're not putting the types in. So I think we need to, up front here, we need to put the types into the identifiers also, not just the procedures, but the types. So then when we come down to here, we have them. Well, I mean, this procedure definition also needs to have the correct types. Yeah, so I'm not sure if that's the issue we're facing here, but I think it is an issue. So we kind of have 2 cases here. If the length of the children if we have a right-hand side and that right-hand side is a type, then we don't just want to do this. I guess we basically want to handle the statement. And then maybe, so we've handled all the statements that are type assignments and procedure assignments. So then maybe down here, we just make sure we don't do them again. And we just do the other statements. Does that work? Well, now we're in generation. Should there be, why is there a left-hand side node? without type information in generation. That doesn't sound right. Oh, so the left-hand side is a type. Because it is a type. It is a type. And if it is a type, it doesn't have a type. It is a type. Which I think we can just do like that, or maybe it's better to say not is type. Do we have two of these? Yeah, there's another one down here. I think we can just do this actually. Like that. Let's try that. Oh, this here also is going to need that check. So it's like the left-hand side cannot be a type. Actually, I'm okay, yeah. So now we're generating an assignment. The left-hand side node is the type struct. So there's nothing to generate if we're talking about a type, right? I want to make that assignment. So I think we can say like if is type left-hand side node, just do nothing for an assignment. Like if we're assigning a type to another type, it's just a type alias. It's nothing to do with assembly. Assembly doesn't know about types, so we don't need to generate anything. Hey, that worked. Okay. Nice. Just for a little more testing, let's alias i64 and see if that works. That also works. Okay. Something a little more tricky that I wanted to try. This is something I'm going to want to use quite a lot, is vec3, which is an array of 3 floats. That's going to be very useful in the future. So let's create a variable of type vec3. Okay, that failed. Why did that fail? Oh, we need to take this away. But it is handy. So we're getting the type of something that is already a type. So we shouldn't be coming in here. We shouldn't be going, well, so this is an assignment, left-hand side node is bar. So we're type checking a primary. Okay, so the child, so this check here, so the node is bar, the child is vec3. Vec3 has not been replaced. This should have been a type. You know, if we go to our assignment code, we should have gone here with vec3. But we don't. My_int is the first place that we do it. Vec3 should have also been. Now we're going to get lots of stuff there. So why would vec3 not go in there? Vec3 equals like that should have replaced it. So that's right print. Let's see if we can find. Okay, yeah, it doesn't go in there. Why not? Well, the reason that we want it to go in there is because we want it to be this. Oh, we're just saying equals type. But because this is an array, let me just check where we use that, because I feel like that's not enough. This is coerced type. I think in that case it's enough. Yeah, these utility procedures, yes, but here, no. I think we need to use is type to handle the more complex cases. So let's go like that. Don't need to stop there. Still have an error. Blah is an index of type F32. So the left-hand side node is bar. Are we still not getting? Yeah, it's still saying it's an identifier. Why would that be? Why is that an identifier? I mean, we have. Is it not? Because I did that fix. I thought that would fix it. So, is it doing it now? Yeah, it's putting it in. It's putting vec3 in, right? And okay. So it's putting the type in, and then when it comes to this line, it should call resolve types, which should then resolve the vec3 to a proper type. And then later when we're in this bottom loop, this is where we should be doing, that should actually evaluate that, right? Oh, wait a minute. Oh yeah, that's fine. So yeah, this is in the bottom loop. This is in the bottom loop. Oh yeah, I was mentioning about this condition before. I think that condition is bad. No, but still that should not be an identifier. I do want to change this, should be is struct member. That's what I'm really trying to say here. But the tricky thing here is, like, why is it not a type? It should have been converted to a type. This node, this vec3, which should have prevented from going in here, because then it would not be flagged as a struct member. So why is it not getting set to a type? Kind of have to. Let's get rid of the test suites so we don't have to skip through so many things when we're debugging. Okay, so we just skip over this standard library stuff, like so. Now we're at this line, so this is where we declare it. So after that, it should be in the list of identifiers. Then we go in here on the next statement. So this is an assignment. We recurse in. Now we're on the left-hand side, bar an identifier. And we recurse into that. And now we should find vec3, right? Which should be in the identifier nodes. So the identifier node is, we've got this equals type again. I didn't check properly. We want to say it is type. So let's make that a pointer. That should work better. Okay, exit code 4. All right. And if we look at the example code, we should see an assignment of 12 bytes with a nil initialization, which is this. We're initializing it to nil, but we have 3 times 4 bytes, 12 bytes. So I think that worked. Okay. I'm pretty happy with that progress. Like we fixed up all the errors from the refactor, and we've done some pretty advanced, I think, type aliasing and gotten it to work. I feel like there's probably, because I've done so much kind of refactoring and rejigging recently, I feel like there's probably so many errors or so many bugs. We really need to revamp our test suite. I have some ideas about how I want to make it a lot more extensive than what it is, and easier to, like, I want it to be so that when an error comes up, it should be much easier to debug and look at the assembly for that specific case. And yeah, I have a lot of ideas about that. I think we should get to that soon. I think I'm going to try and get this multi-threading done first, because I talked so much about it and then never got it done. So let's get the multi-threading first. Hopefully now that we have structs, it might make it a bit easier. I have to have another look and see if we've got enough features now. We might need more features. Hopefully we've got enough. I hope you enjoyed. This is a bit of a shorter one today, but I feel like there's not really anything particular that I want to, like, add to this right now. I think this is a good point to stop. Yeah, so thanks for stopping by. Have a good one. Ciao for now.